All right, class, so this is the heating curve problem that we were doing in class today. It says, imagine you have 350 grams of hot water that is 80 degrees Celsius, and you want to cool it to 25 degrees Celsius, and then it asks how many grams of ice, that is minus 10 degrees, do we need to add? So the first thing that I'm going to do is I'm going to draw my little picture diagram to sort of guide how to do this problem. And the diagram that I would draw is going to look like this, where right here I would have 80 degrees Celsius. This would be 0 degrees Celsius, and then this is my starting point of minus 10 degrees Celsius. So this right here would be my starting point for my ice, and as my ice gains energy, it's going to move left to right. And then this right here would be my starting point for my hot water. So this is start for hot water. That's at 80 degrees, and I've got 350 grams of that hot water. And this right here would be my start for ice. And they're going to meet right here at 25 degrees Celsius. So in this problem, we're given what our final temperature is. So that's 25 degrees Celsius. So we can sort of already say, well, this hot water is going to cool down. It's going to lose energy to get to this point. This ice is going to gain energy. It's going to gain energy in sort of 3 portions. So we'll label these 1, 2, and 3. It's going to gain energy in 3 portions so that we get up to this 25 degrees Celsius. So since we already have all the information we need to find this amount of energy, I would say that's a good starting point for this problem. So we're going to look at this from the point of view of the hot water. Q equals S times M times delta T. That's going to equal 4.184 times my mass, which is going to be 350 grams. And then T final minus T initial. So we've had some confusions with this T final minus T initial, so I just want to be really explicit here. In this case, T final is 25, and T initial is 80. So this is going to equal minus 80,542 joules of energy. So it's going to be a minus sign here because 25 minus 80, that gives us minus 55. And this represents that this is the amount of energy that's lost by the hot water. So if we think about, we're starting here from the point of view of the hot water. As I go from right to left, I'm losing that energy. I'm losing that energy to the ice. So this value here is minus 80,542 joules. And all of that is going to be transferred to this ice. So from the point of view of the ice, positive 80,542 joules is going to be gained. So that's where the sign difference comes into play, and we need to understand what's going on there, really understand the sign convention here, and why we're changing the sign essentially. So this is positive 80,542 gained by the ice. Now the ice is going to gain that energy in 3 steps, 1, 2, and 3. So in step 1, the ice is going to heat up to 0 degrees. And the amount of energy that's going to take, again, we'll use Q equals S times M times delta T. The S value here, that's going to be the S value for solid water or ice. That's 2.01 joules over grams times degrees Celsius. Times my mass of ice. We don't know what the mass of ice is. That's my unknown in this problem. So I'm going to put in X grams of ice. That's my unknown. And then my delta T, this would be T final 0 minus T initial minus a negative 10, that's going to be 10. So this will be a positive value, right? My mass should be positive. So this will be a positive value of energy because it's gaining that energy, right? The ice is going to be gaining energy as I go from left to right on this graph. So this is the expression for step 1, the amount of energy. We don't know what that is, but that's okay, right? Because this expression here, that's going to tell us, this amount of energy plus this amount of energy plus this amount of energy will equal this total amount of energy that's gained by the ice. So let's look at step 2. So step 2, we're going to do a phase change from solid to liquid. Therefore, we're going to use the delta H of fusion. So the delta H of fusion times the number of moles, that will give us to the amount of energy that we need. So 6.01 kilojoules per mole is the delta H of fusion for water. So now I need to come up with the number of moles. And I have X grams, but if I multiply that by 1 mole over 18.02 grams, so this is just converting from grams into moles, right? If I knew how many grams it was, then I would just convert using the molar mass of water. But if we don't know, right, we can just use X over 18. That will convert to moles. Now the last thing I'm going to do here is I'm going to convert from kilojoules to joules. 1,000 joules for every 1 kilojoule. That's going to convert this into joules. And everything else so far is joules, so I want this to be in joules as well. Step 3, heat 0 degree water to 25 degrees. So once we've melted that ice cube, right? So right now we're at this point. Now we need to heat it up to that final temperature of 25 degrees. We want everything to be at 25 degrees. So I'm going to need to heat it up. So again, Q equals S times M times delta T. We're going to be using the S value for liquid water now, 4.184, again, joules, times X grams. We don't know how much it is yet. And then times by 25. 25 minus 0 is 25. T final minus T initial is that value there. So now 1 plus 2 plus 3 should equal 80,542 joules. So we already know all of this energy that's lost by the hot water should be gained, right? So if I draw an arrow going this way, this arrow should be the same amount of energy as the energy that's lost, but the sign should just be opposite, right? So this was a negative value because we're losing energy. This should be a positive value because we're gaining that energy. So now I got this really big, I can add all these up, really big equation with only one unknown, which is my X value, and I can go ahead and solve that. So let's write all of this out. So now we're gonna say 2.01 times X grams times 10 plus 6.01 times X times 1 over 18.02 times 1,000 plus 4.184 times X grams times 25. And all of this is going to equal 80,542 joules. So I'm not going to show all of the algebra here, but basically just grouping everything together. I'll skip ahead. So this all will end up equaling 20.1 times X plus 333.5 times X plus 104.6 times X, and that will equal 80,542. Again, just grouping those together, we can end up finding that X equals 176 grams. So that is my final answer for this problem. Again, the whole idea here is not that you can memorize this process, right? That is totally not going to help you out in the long run and not what I'm asking you to do. What I'm asking you to do is really understand the process. Why, am I doing this? What does this represent on my graph, right? So here's my graph. Can I come up with a graph, number one, and then also figuring out what steps to do? How does each one of these relate to my graph? And then why am I sending them all equal to each other and all that sort of stuff. So it's really all about the whole process of the problem, not just getting to this final answer. Obviously that's important, right? We need to be able to do that. But really I want you guys to focus on the process of the problem. All right, hope that helps.